The lesson outcome for this video is I can multiply polynomials, day 2. Alright, so the first two examples you see in front of you are just a review of the first day of multiplying polynomials. So if you could just pause the video, try these two problems in your notes, and then check back to see how you did, that would be great. You may use the distributive property or the array method, whichever you feel most comfortable with. Okay, so this first one I will do using distributing, and we will get 5 times 3x, which is 15x, and then 5 times negative 7, which is negative 35. The second example I will do using an array, which is a 1 by 2 array, because there's a one-term polynomial, so a monomial here, and then we have a binomial here. So we're going to put 2x squared in the first column and 3 in the second. When we multiply the 4 times the 2, which is 8, and the x times the x squared. Well, this is 1x, this is 2 more x's, so we're going to have x times x times x, which is x to the third. When we multiply 4x times 3, we get 12x, don't forget that x, and you should have arrived at the answer of 8x to the third plus 12x. Okay, so these next two examples are a little more complex. In both cases, we've got a binomial times a binomial. Again, 2 terms multiplied by 2 terms. The first method I'm going to show you is what we call FOIL. And you may have heard of this before, but if not, that's fine. It's an acronym that stands for first, outside, inside, last. FOIL. What that means is we're going to multiply the first terms first, okay? Meaning the first term of this binomial, which is 4x, times the first term of this binomial, which is 2x. So we're going to do 4x times 2x, and that will give us 8x squared. Okay, so some people still use like the arrow kind of look. Let me show you here what I mean. Some people still do this kind of thing like this. So that's the first terms. Let's make that work a little bit better. Okay, so the first terms. That's these. All right, then we multiply the outside terms. The outside meaning the outside of the whole expression. So this outside term here and this outside term here would mean this. So that's outside. Well, 4x times 3 is 12x. Then we would use I, which stands for inside, so the inside terms, so that's these two here. So negative 9 times 2x, which would be negative 18x, so minus 18x. And then, of course, L stands for then last, the last term. So take the last term of this binomial, multiply by the last term of this binomial. So that would be negative 9 times positive 3, which is negative 27. Now after you do all that, what we call foiling, we use a verb there sometimes, we then need to combine any like terms. We have an x squared term here, and that doesn't have any like parts, any other common terms, so 8x squared. Then we have positive 12x and negative 18x. Okay, those are like terms because they both have the same variable part, which is an x. Well, positive 12x and negative 18x will give us negative 6x. And then lastly, we have the negative 27, and that is our final expression. Now, FOIL is a fine method. Some people really like it, but I prefer to use the array model that we've already discussed. The array model, in my opinion, keeps it a little bit more straightforward. Okay, I just realized that before I do any of this here, hold on. Okay, so I just deleted that other binomial times a binomial, that problem that was right here. I'm actually going to do this same problem using the array method so you can see how we're going to get the same answer in the same work technically, but a little different organization. So if you had that other expression written down, you can either cross it out, erase it, or we'll come back to that in a little bit. So I'm actually going to still do 4x minus 9 times 2x plus 3, again, just like I did over here. So same problem. Okay, I'm going to start by drawing an array that is a 2 by 2, because we have a binomial times a binomial, which means it's going to be a square. All right, and then I'm going to write 4x here and negative 9 here. Again, the 4x goes here and the negative 9 here. Then I will put the 2x and the 3 in. And again, the 2x is from, sorry, hold on. The 2x from here and the 3 here. Now I will multiply each part to fill in the array. So first I'm going to multiply 4x times 2x. Well, 4 times 2 is 8, and x times x is x squared. So I have 8x squared. Then I'm going to multiply, and it really doesn't matter what order you do this in, I'm going to multiply negative 9 times 2x. So negative 9 times 2 is negative 18x. Then I have to do these two. So I'll do 4x times 3. 4x times 3 is 12x. And lastly, we have negative 9 times 3, which is negative 27. Now notice, we have these 4 terms are the same exact 4 terms that we had right here. Okay, the 8x squared, the 12x that's positive, the 18x that's negative, and the negative 27. When we rewrite this, we are going to first look for any like terms in our array. We have an x squared term and no other x squared term. We have an x term and another x term. Because those are both x terms, we can combine them together when we write our solution. So we get 8x squared, and then we can combine these by just taking a look at negative 18x and 12x and say, oh, that's negative 6x, and then minus 27. Again, notice we have the exact same expression as we got over here, just using a different type of organized method. Again, your call. This might feel more organized to you. Whichever one you want to use is fine. So here's that other example that had been previously on the screen and then I had erased it. Go ahead and try this example. You can either use the array or use FOIL, and then come back to check to see how you did. Okay, so again, it's a binomial, 2 terms here times 2 terms here, so I would need a square array that goes with both directions. So 2 terms, 2x squared and positive 1, 5x, and negative 3. All right, so let's do some multiplying here. We're going to do 2x squared times 5x. Well, 2 times 5 is 10. And then we have x squared times x. Now remember, this is x times x times x. Well, what's x times x times x? Well, it's x to the third. All right, then we have 1 times 5x. Well, 1 times 5x is 5x. Then we have 2x squared times negative 3. 2 times negative 3 is negative 6. And then we still have the x squared. And lastly, we have 1 times negative 3, which will be negative 3 in this square. Looking for like terms, what we see in this case is we see an x to the third term, an x to the second term, an x term, and a constant. None of these 4 are like terms. So when we're done with this expression, we will have 4 terms, none of which can be combined. So we just write them out, 10x to the third minus 6x squared plus 5x minus 3. Now when you write them down, you can write them in any order, but then notice that I ended up writing my answer in standard form, where x to the third comes first, x to the second next, x to the first next, and my constant last. And for our last example today, I'm going to have you take a look at multiplying a trinomial times a trinomial. Again, 3 terms by 3 terms. Again, when you make your array, which is what I'm going to do, you just need to have the same number of columns as number of terms here and same number of rows, or vice versa. So since it's 3 terms by 3 terms, I'm going to make a square array again, but I'm going to make it a little bit bigger so I can make sure to fit all my terms in there. There's my array. Looks kind of like tic-tac-toe. All right, so we have 3x squared, and we have a positive 2x, and we have a negative 5. The other polynomial has 4x squared, negative x, and positive 2. If you'd like to pause the video and try this on your own and see how you do, go ahead. If you'd rather watch this example, that's fine too. Just also include it in your notes. All right, so 3x squared times 4x squared. We can multiply the coefficients. 3 times 4 is 12. And then we multiply the x squared times the x squared. Again, think about it like this. X times x times x times x. That means we need to multiply x times itself 4 times, so x to the 4th. I'm just going to work my way down. Again, you could go this way. You could actually jump around and put whatever in wherever you want to at any time. At the end is when we'll write it in order. So 2x times 4x squared. 2 times 4 is 8. And x times x times x is x to the 3rd. So 8x to the 3rd. Then we have negative 5 times 4x squared. Negative 5 times 4 is negative 20. And we have the x squared. Negative 20x squared. Okay, now we're going to go ahead and do 3x squared times negative x. Notice if you wanted to put a negative 1x there, you could, if it makes more sense to you. So 3 times negative 1 is negative 3. And we have the x squared times the x. So x times x times x is x to the 3rd. 2x times negative 1x is negative 2x squared. X times x, so negative 2x squared. Negative 5 times negative 1x. Negative times a negative is positive. 5 times 1 is 5. So we have 5x, and it is positive. 3x squared times 2. Well, 3 times 2 is 6, so 6x squared. 2x times 2 is 4x. And lastly, negative 5 times positive 2 will be negative 10. Now looking for like terms. I have a 12x to the 4th. There's no other x to the 4ths in this array. So I'm going to write 12x to the 4th. And I'm going to see, okay, I have negative 3x to the 3rd, and I have another x to the 3rd here. So I have 8x to the 3rd and negative 3x to the 3rd. That will give me 5x to the 3rd. All right, because the coefficient 8 and the coefficient negative 3, so we've got 8 minus 3 is 5. So plus 5x to the 3rd. And again, they're like terms, but you do not change the exponent here, because like terms means you just combine their coefficients. So it's all x to the 3rd power. 8 minus 3 is 5. Now, you might notice that we also have, let's see here, we also have an x squared term here, and an x squared term here, and an x squared term right here. So that means we have negative 20x squared, negative 2x squared, and positive 6x squared. Well, these two added together is negative 22x squared, and add the 6 to it, and we're going to have negative 16x squared. So negative 16x squared. Okay, again, negative 22 plus 6, negative 16x squared. All right, then you might also see we've got an x term here and an x term here. What's 5x's plus 4x's? Well, that is 9x's, so plus 9x. And lastly, we have this negative 10 here, so minus 10. Here's our final expression when we multiply two trinomials.